Okay, one of the first items that we're inclined to look for when we were reading any kind of research article, people tend to want to see some kind of picture, whether it's a graph or bar graph, that kind of thing, the actual numbers themselves and how they're distributed, because it gives them a better understanding of reading the text if they can compare that to another set of data. So, for example, this is one way in which data can be represented, and what this shows us is this is age of participants in a study. So there's students that are 18 years old, students that are 19-year-olds. This is the type of data. This shows us how many, the frequency by which this value is represented. This shows us, this percent, the actual percent of people that this group represents. So this 213 is 17.7% of the entire sample. Some data points also show a valid percent. When we get down to the bottom of this, we'll see why that's important. And then it also will continue to add these together. So when we get to the 19-year-olds, there's 302 of those. That group individually is 25.1%. It is valid. And if we add that 25.1 to the 17.7, we get 42.8. And this keeps working its way down. Now, we get down to 23. What they actually mean is 23 and 24-year-olds. So there's 75 of those, 6.2%. And there is a group called 24, which is actually anybody that's 25 and older. 72 of those, 6 of those. And we're going to see something odd here. We have one person who put that they were 99 years old on this study that was being completed. More than likely, the person who filled that out is not 99 years old. They either did it being facetious or made a mistake or something like that. So it gets included in the percent, but it's not necessarily a valid percent because it gets kicked out. And the computer knows that for some reason that doesn't need to be included. So this is just strictly frequency data, percents, valid percentage, cumulative percents. Okay, and we kind of went through that. Now, sometimes we'll want to see a picture. So if we look at this picture, this is a different set of data. Sorry about that. This is called a stem and leaf plot. And basically what it shows is there's a stem, a base number here that's in the 90s. So there's two values here. There's 90 and 96. There are 5 values here. There's 71, 76, another 76, another 77, and another that's 88. So we have this grouping of information. Here we don't see anything, so there's no values in the 20. This is called a stem and leaf plot. Now, that being said, it's not as common as it used to be. That, however, could be turned into something like this. So, for example, as we said, there was 2 people that were in this group here, 3 people who were in this group here, etc., etc. The problem with this is we lose something with it. We don't know specifically what numbers were in this 90 to 99 range like we did here, nor do we know what numbers were in the 80 to 89 range. We just have a group like this. This is called a histogram. It is fairly common, but more than likely what you're going to see is something that looks more like this. And hopefully you'll see that what this is, if you were to draw a cursor over the top of that, is a normal distribution. There's a lot of them right in the middle. That middle 68%. As we work our way away from either standard deviation, or excuse me, from the mean to these other standard deviations, we see less and less, just like that normal distribution curve. We've already had an activity on standard deviation, so we're going to go on to this other part about the interquartile ranges. Another way in which numbers are distributed is instead of doing it into those standard deviations, they'll do it in these quartile ranges. They'll divide the data into 4 groups. So quartile 1 is 0 up to 25% of the group. Quartile 2 is 25 to 50% of the group, etc., etc. And the middle of it, the group between quartile 1 and quartile 3, is something called the interquartile range. Now, if you remember back to our normal distribution curve, we had a middle 68%. Well, this is what we call a middle 50%, and it's just a different way of looking at the information. Again, it depends on normal distributions, and it's just a different way of looking at how the data is grouped. Another example is called a box and whisker plot, and this is taking the interquartile ranges Q1 and Q2 and it's kind of giving it a picture. What a box and whisker plot does is it shows you the middle 50% from the 25% of the group up to the 75% of the group. This is the middle 50%. And it also shows you how far out away from the median, how far away from the lower quartile is the first quartile. So this whisker gives you an overall picture of how the data is distributed. Now, what we'll see is if this box is very, very wide, then the actual data from this point to this point is very wide. Sometimes this box will be very, very narrow, and that means that the data is clumped up around the middle. So going back to the types of kurtosis, we'll jump back a few slides. Sometimes, as we said, normal data is clumped up in the middle. It's called a leptokurtic curve. Well, that works with interquartile ranges as well. So let's look at this example, and this is, I believe, a chemistry example. But what I want to show you is these are box and whisker plots, and they're turned up on their end. So we look at this one. Here's the interquartile range. And here's one with an interquartile range. So this would be an example of data that has a leptokurtic distribution. This is an example of data that has more of a platykurtic distribution. All this is really good for is to give you an idea of how the data is distributed, how clumped together it is, and where the data gets distributed. So if we look at this one, we'll see it has a very, very narrow interquartile box, and it has some data that is way out on one end. So this is something with a positive skew because there's a few data points out here at the top that are spreading out this top quartile, as opposed to this, which is spread out kind of in the middle, and there's not much distance in between the first quartile and the bottom and the third quartile and the top. So this tends to be more of a normal distribution. Here's one with a negative distribution because there's something at the bottom that's pulling this whisker down. Now, that being said, this is not the easiest thing in the world to read, and you lose a lot of the data by not having the numbers associated with it. Okay, that's where we're going to stop with Chapter 2, and now we'll move on to Chapter 3.